Alright, this is part 3 of our lesson on 1.4 complex numbers in Trig. So let's take a look here at example 9 and see what we can come up with. So with this one, 3 minus 5i, you can't have i's in the bottom. You can't have them in denominators, right? Because you can't have roots and you can't have exponents with fractions in the denominators. So this is 3 minus 5i, so the conjugate would be 3 plus 5i on both the top and the bottom. So this is what I'm looking at, a whole bunch of stuff to FOIL. 7 times 3 is 21. 7 times 5i, which I guess I'll just stop right there and we'll walk through all this in the bottom. So 7 times 3 is 21. 7 times 5i is 35i. Negative I times 3 is a negative 3i. Negative I times 5i is negative 5i squared. And if you remember the rule, 3 times 3 is 9. 5 times 5 is 25, if you remember the rule with conjugates. So we combine like terms. 35 minus 3 is 32i on top, and that actually becomes a negative 1. Negative 1 times negative 5 is positive 5. 21 plus 5 is 26, not a 36. So let's see here. It's a 26, not a 36. Okay, so 26 plus 32i, you can divide a 2 out of all those numbers to simplify. So we take that 2 out, and it's actually 13 plus 16i over 17 as your answer. Working with square roots of negative numbers, it's the same thing. Okay, you're looking at this stuff. It's not meant to baffle you at all. When we go to do this, remember, I can separate this as the square root of negative 1, the square root of 9, the square root of negative 1, the square root of 4. And the reason why I'm doing that is so you can see, hey, that becomes I, and that you already know that that's a 3. This becomes I, and this becomes a 2. So really what I'm asking you to do is, hey, what's 5 minus 3i and negative 1 plus 2i? That you know how to do, right? You just FOIL it. This is what we've been doing. 5 times negative 1 is negative 5. 5 times 2i is 10i. Negative 3i times negative 1 is positive 3i. Negative 3i times 2i is negative 6i squared. 10 plus 3, that's 13i when we combine like terms. This right here, it's a negative 1, so negative 6. And negative 1 is positive 6. Negative 5 plus a 6 is 1, so we get 1 plus 13i as our answer there. So, taking a look at this one, same dealie as before. Let's pull out that negative 1. Let's pull out that negative 1. That becomes an I, and square root of 16 is 4. That's how I get a 4i there. This becomes an I, and that becomes a 5. That's how I get a 5i. And the minus is still there, and the negative 4 is still there. So this foiling, 6 times negative 4 is negative 24. And I'll finish that up here. 6 times negative 4 is negative 24. 6 times negative 5i is negative 30i. 4i times negative 4 is negative 16i. 4i times negative 5i is negative 20i squared. Negative 30 and negative 16 is negative 46i, and that's a negative 1. So negative 1 times negative 20, it's a positive 20. And 20 and negative 24, it's a negative 4. So negative 4 minus 46i. That doesn't you compute. So example 12, we have a quadratic now, and we ran into these at the end of the last problem. So we can use the quadratic formula to solve, not a big deal. This is A, that's B, and that's C. We went over this in the last section. So this is 2. That's 2 squared minus 4 times A is 5, C is 1, A is 5. So when we do this, we end up getting a 4 minus 20, which is the square root of negative 16. And we just said, hey, we separate that into root 1, and square root of negative 1, and the square root of 16. The square root of negative 1 is I, and the square root of 16 is 4. So now we can divide each of these by 2, and we get a negative 1 plus or minus 2i divided by 5. So just something else to keep in mind when you're doing these problems. So with this one, I add 1 because it's the sum and difference formula if we want to do that. So remember the sum and difference of cubes, because I can rewrite this as something cubed. It's 1 cubed. So remembering the formula, this is x minus 1 in parentheses. Then it's the first item squared. Then you multiply them with an addition sign, and then it's the last item squared, which is 1. So when you go to solve this, hey, no problem with that one. X minus 1 equals 0. That's 1 as your answer. But what about this? Got to solve that. So when we do this, we get 1 as our answer. But you know what? I know you could have just solved it that way, and you would have gotten 1 as your answer up top, because a cube root of 1 is 1. However, the reason why you have to split it up and do the sum and difference of 2 cubes is because we end up getting 2 imaginary answers that work. Every time you have a problem, this little degree tells you how many answers you're going to have. 1 is just one answer. It's supposed to be 3, which means there's 2 answers that are going to be imaginary. So A, B, and C are all 1s. You're just plugging in 1s everywhere. That's a negative 1. That's 1 minus 4 divided by 2. So negative 1 plus or minus root negative 3 over 2, which is like saying I root 3. These are your other 2 answers. They're imaginary, but they work. If you plug those in, you will solve that problem. Okay, as crazy as it sounds, you plug in those 2 answers, and that will solve the problem for you, as well as the 1. So, if you have any other questions or concerns with complex numbers, anything with i's, please let me know, email me, and if not, I hope this was enough to help out.